All right, you say 5. And these were just setup problems. Okay. A post office requires different numbers of full-time employees on different days of the week. The number of full-time employees required on each day of the week is given in the table below. Union rules state that each full-time employee must work 5 consecutive days and then receive 2 days off. For example, an employee who works Monday through Friday must be off Saturday and Sunday. The post office wants to meet its daily requirement using only full-time employees, formulate a linear programming model that the post office can use to minimize the number of full-time employees that must be hired. So it seems like a dearth of obvious inequalities to write here. You guys agree with that? Okay. So what even would be the variables for this problem? The number of employees working each day of the week. Yeah. So let's call these, we'll do Monday, Tuesday, Wednesday. I'm going to do R for Thursday, F for Friday, S for Saturday, and U for Sunday. Is that really what I want to do? Is that really our variable? Let me think for a minute. So if that's what we're going to call our variable, how are we going to figure out the minimum number of full-time employees that need to be hired? Okay, but the one employee is going to work each employee is going to work 5 of those days, or up to 5 of those days. So you'll be counting the same employee up to 5 times. And not every well, I guess then, yeah, we could do that. We could add them all up and divide. It does say that everybody has to work 5 days exactly and have 2 days off. Right? So that would work. So then our cost function would be minimizing the sum of those divided by 5, right? Since one employee is going to work on 5 of those days, right? Or each employee, I guess I should say, is going to work on 5 of those days. Now, does the divide by 5 really need to be there? If something's the minimum of M plus T plus W plus R plus F plus S plus U, is it also going to be the minimum for that divided by 5? Yeah, right? Like, what's the smallest number between 1 and 10? What's the smallest number divided by 5 between 1 and 10? Still the same number, right? You kind of get what I mean there? Okay, so now let's start worrying about these constraints. So there's one obvious set of constraints. I have this separate somewhere. It's driving me crazy trying to scroll back and forth. There it is.
So are the constraints just like what you actually need?
So this is just things that have to be true for the problem. So these are things that must be satisfied. We know that we need at least this many employees each of those days, right? Okay, so that's easy. But then there's a bunch of other things inside the problem, right? Specifically, it says that they have to work 5 consecutive days and then have 2 consecutive days off, right?
So does that mean like they could start on any day of the week?
Yeah. So, for example, if we talk about the possible schedules, you could do Monday through Friday. And then you'd be off Saturday and Sunday. You could go Tuesday to Saturday and be off Sunday and Monday. You go Wednesday through Sunday and be off Monday and Tuesday. You could go Thursday through Monday and be off Tuesday and Wednesday. You could go Friday to Tuesday and then be off Wednesday and Thursday. You could go Saturday to Wednesday and be off Thursday and Friday. Or you could go Sunday through Thursday and be off Friday and Saturday.
So do you really need to put that down?
Well, I don't know. We're just trying to figure out how to write the constraints. And this seems like something that's an important thing to come up with on how to represent this with an inequality, right? I don't know if it's going to be useful or not right now. But it seems like that's an important observation to have made, at least, that there are, 7 different schedules here that we could have written. Do you guys agree with that? That each one of those is a plausible schedule. So what else can we say here?
The possible schedule is
No, this is just like some note that we've written down.
when there has to be
Oh, like
about like 50 days off.
Yeah, but that's going to be kind of in. Yeah. I mean, yes. But whether you want to talk about that being 5 days in a row or 2 days off is basically the same thing, right? If you're in a what just happened? If we're in a 5-day work week, whether you work 5 days in a row or whether we talk about it that way or talk about 2 days off is basically still the same thing, right? Anybody with an idea? Anybody have an idea here on what to do? Yes.
So they want to get less full-time employees.
You want to have the minimum number of full-time employees. Yes. That wasn't helpful. Okay, well, let's think about this way then. I'm going to go back to this possible schedules, and I'm going to just kind of rewrite this in a different fashion. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. For the first possible schedule, we're off those days, but we're on those ones, right? For the second schedule, we're working these days, but we're off those days, right? The third schedule, we're off Monday and Tuesday, but we're working the other 5. And then kind of continue. So there's 7 total schedules, right? So you could do that, but what is it got to be constrained by? Just the sum of those workers on those days? But then that's no different than just listing those 5 constraints separately, right? But that's, I like where you're at, though. I think that's where we need to be at. Let's, instead of looking at it as these constraints as a row, what if we look at them as a column? Right? So each schedule is going to have 5 Tuesday workers, 5 Wednesday workers, 5 Thursday workers, 5 Saturday, or Thursday, Friday, Saturday, Sunday, right? So we want to do that. Is that a useful piece of information? Hmm. This is tricky. This is tricky, right? Not as obvious as the past one. I'm not even sure that we've picked the best variables. Hmm. 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 Well, let's think on it for a bit longer. We'll come back to this another day, perhaps. I don't have any great ideas off the top of my head right now. You guys seem like you're stumped and not really not throwing out anything else that we can kind of build on. So let's stop and walk away from it and come back later. That's sometimes helpful. Joe?
I found the answer.
Okay.
Just make a note.
Okay. Well, why don't you let's look at the answer and see if we make some sense out of it then. Do you have the link that you can email me? Okay. Let's do that then. That's something.
How many power?
That's fine. Again, like, not an unreasonable thing to do, right? You're stuck on a homework assignment. Let's look at the internet. There's nothing wrong with doing that. Okay? Let's make some sense out of it, though, because if we just, we don't want to just copy it down, but if we can make some sense out of it and understand what they did, we can use it, use those ideas going forward, and that's a good thing.
It seems like really.
Okay, well, that's okay. We'll take a look at what they did, and I'll let you guys know if it's a reasonable thing to have come up with, or how they came up with it, or what's going on, but Let me know when the email is on its way there, Joe. Okay. Again, this is part of being resourceful, right? You run into a roadblock on a homework assignment that you know is difficult. Your teacher's told you that this is difficult, right? Okay, let's see if anybody else has any ideas. I'm out of ideas. Shouldn't be your first thing you go to, but not an unreasonable thing to go to after you've been stuck on it and you're like, I just don't know what else to do with this. Joe, you got that email on its way?
Yeah.
A Kulick, Kulick. Okay. And this is great, right? Like, we have somebody else's answer. Now, be wary. Sometimes answers on the internet are wrong, right? Yeah, that doesn't mean that it's necessarily right either. You know, it could be somebody's homework assignment that they just have floating around on the internet that they did wrong. You know, could be somebody that copied some answer out of the back of the book and there's a typo in the back of the book, or from a solution manual and there's a typo in the solution manual. Like, there's lots of stuff that gets on the internet from pretty reputable places. You know, it's very possible that it's correct.
It starts on like the 7th slide.
Okay. I still haven't gotten an email come through. What did you search? Okay. Let's try that. The post office requires different numbers. And then UT Dallas, is that the... Okay. Yeah, that's fine. Put it there. Okay. Let's do this, since apparently we're having slowness problems. What is going on? Just stop. Okay. So that reads, I think, exactly as ours does. And that's the same set of constraints, or the same set of data anyways. Okay. So their variables are going to be the same as ours. So they did number 1, who are going to be working Monday. Oh, they're doing schedules. Okay, so that's fine. So they're doing their variables as the different schedules. So they have 7 different variables for the 7 different schedules. That's fine. So their minimize is going to be, okay, so just the sum of the workers for that schedule. And then, yeah, so that's basically what we have there. Yeah, okay. And that's something. Okay, so that's fine. We can talk through that now. Okay. All right, so we were almost there. If that makes you feel any better. We're very close. Okay, so what we're going to do differently is we're going to have our variables are going to be S1, S2, all the way out to S7 for the 7 different schedules that we've outlined there. Okay, and this is the number of workers for each of the 7 different schedules. So for Schedule 1, we need S1 number of workers. Schedule 2, we need S2 number, etc. So using this table here that we formulated, let me just copy it down. This is how we're going to formulate our constraints. So we're still going to minimize S1 plus S2 plus S3 all the way out to S7. So our objective function is still going to remain the same. And now what we're going to do is we're going to look at each of these columns. So Schedule 1 has workers on Monday. So do Schedules 4, 5, 6, and 7. And that number has to be greater than the number of employees that we require to work on Monday. And my OneNote is just wanting to be a dinosaur again. Does that make sense? So we're going to have some number of workers that are going to work the Schedule S1, the Monday through Friday schedule. But we also have workers that work on Monday in Schedule 4, Schedule 5, 6, and 7. So all of those, sum of those workers for each of those schedules has to be at least 19, the number of workers we need to cover Monday's routes. And now we'll do the same thing with Tuesday. So the people or the schedules that work on Tuesday is Schedules 1, 2, and then 5, 6, and 7. And that has to be at least the Tuesday demand. And we'll continue doing this for each of the days. So for Wednesday, that's Schedules 1, 2, and 3, as well as Schedules 6 and 7. And that has to be at least 15. And then for Thursday, that's Schedules 1 through 4 and then 7. That has to be at least 19. And then for Fridays, that's Schedules 1, 2, 3, 4, and 5. And that has to be at least 14. And then for Saturdays, that's Schedules 2, 3, 4, 5, and 6. And that has to be at least 16. And then for Sundays, that's Schedules 3, 4, 5, 6, and 7. And that has to be at least 11. And that will do it. Oh, we have one other thing, though.
I'm just confused on the PowerPoint. Why does it have like XJ?
Don't worry about that for right now. We have one more thing to concern ourselves about, though. Because right now, there's no reason that we couldn't assign the value of like 6.3 to S1. Does that make any sense? S1 is representing a worker. You can't have a third of a worker, right? So we need one other requirement. It's that each of these values of s must be, must be integers. Really specifically positive integers, right? We can't have negative number of employees either. Where did my PowerPoint go? And this is just them saying that all of these values for x, x1, x2, x3, x4, x5, x6, x7 has to be greater than or equal to 0. That's just a fancy way of writing that. Is all that is, Joe. Is that okay? Better than before. So we took care of that here by saying they also had to be whole numbers, because we're not going to allow, or positive whole numbers, because we're not going to allow decimal answers here. This is actually a harder kind of a problem. This is called a integer program instead of a linear program.
You said S was the
Number of workers for that schedule. And we just numbered our schedules 1 through 7 that we wrote down over here.
so like 1 is Monday, right?
Schedule 1 is the workers that go Monday through Friday. Schedule 2 are the workers that go Tuesday to Saturday. Schedule 3 are the workers that go from Wednesday to Sunday, et cetera, et cetera. Is that okay?
Yeah.
Well, thanks, Joe. That was helpful. We were quite close, though, right?
Yeah.
We were circling around what to do there. What was our hang-up? That we chose kind of the wrong variable, right? Rather than looking at the number of workers that worked the schedule and using that, we took the number of workers that were working per day. And that was getting us into trouble. Is that, you guys see the difference there? And you notice, if you remember in the beginning, I was a little apprehensive about choosing that as our variable. And it was like, it'll probably be fine. And that's, kick myself for that.